Hello dear friends, welcome to BYJU'S Exam Prep and I welcome all for this second session of Algorithms Maha Marathon series. Okay, good morning to one and all. Am I audible, visible? Dear friends, very good morning Aryan Karo, very good morning. Nice to see you back. Okay, please join. We are starting the session, right? So in the first session, we introduced the basic concepts. So let us complete the algorithms formalities in this session. Very warm welcome and good morning. Ayush Thakur, good morning sir. Very good morning sir. Okay, hope you are all doing well. And how is the preparation? How the preparation is going? Rock solid? How is your preparation? Suraj Mishra, good morning sir. How is your preparation? Is everything going well? As per the plan? Yes, wonderful. How is the Josh? How is the Josh? Kushi, very good. Yes, very good. Nice. Yeah. And we have this marathon series daily, morning and afternoon. Okay. And not just for, very good, Suraj. Very good, Aish. Not just for CS, my dear friend, even for EC, electrical, IR also, we are having this particular marathon series. Even in other channel where we are having civil and mechanical marathon series are going. Very good. And with this high spirit, with this high josh, you all should get very good rank. Okay? Right. I should hear from all of you. And you also have this, workshops which are regularly conducted by BYJU'S Exam Prep, and Abhinav Negi sir is coming on live on 15th January at 12:30 p.m. for this mega workshop on 7 success mantras from a beginner to a topper in GATE 2024. Okay, you can inform your friends, juniors. And this is about me. Hope you all know about me. So before people join, let me introduce myself once again. For those who are new here, myself Sridhar Dhulipala, having 20 plus years of teaching experience, and this is my Telegram group where the PDF for today's class will be posted, and it is password protected. The password will be revealed somewhere in between. So please keep telling me or remind me about this password, sir, sometime, because it is a dynamic password generator. Am I clear? We are not going to, I not planned it. So we plan the password dynamically. Okay. Hello, sir. Kaustub Nageshwar Garu. Bhavanara. How are you, sir? Right? Wonderful. So this is about me, myself, Sridhar Dhulipala, and I am associated with BYJU'S almost, so by March I'll be completing 2 years at BYJU'S, and we worked on this particular project called Recorded GATE Content. First of its kind, we created visualized animated content, and if you want to see my recorded lectures, please download BYJU'S Exam Prep app under that category name, no doubt. Learn with video lessons. You will find all these subjects which were recorded by me. Engineering mathematics for all branches. For computer science exclusively, we have discrete mathematics, algorithms, C programming and data structures. Hope you understand. Right? So with that, let us start. And of course, we completed these 3 topics in the first part. In today's lecture or today's session, we'll see the problems on Huffman coding, optimal merge pattern, job sequencing problem, fractional knapsack problem, and the dynamic programming problems like matrix chain multiplication, LCS, longest common subsequence problem, and knapsack problem. You're all ready? See, if you properly prepare, that would be enough, sir. That would be enough. Of course. Is it mathematics? It's not mathematics, no, my dear friends. It is algorithms. Ready? And graph algorithms, we'll see the MST algorithms as well as shortest path algorithms. Ready? Let us start with the first problem of today. The minimum number of record movements required to merge 5 files of length 10, 5, 20, 25 and 30. See, there are two questions which you can expect from this optimal merge pattern. The minimum number of record moves, minimum number of comparisons. Am I clear? So that number of comparisons question they can ask you, or number of record moves they can ask you. For both, we require to construct the tree, my dear friends. Binary tree. Am I clear? With these fellows as leaf nodes, and we have to create the internal nodes. Am I clear? So let us solve the problem. Waiting for your solution. So I'll be giving 1-2 minutes time for you to answer. If you answer it, fine. Otherwise, I'll go with my regular procedure. 90, that is, you are giving the final answer of, the value of root node. But I want total number of record moves. Because if you want to merge the final two, the files, before that the small files need to be merged together. Finally, the two files will be merged to form the biggest file. Okay. Aryan Kaurav says 190. Very good. Very good. Super. Simple problem. So here we just need to arrange them in the order 5, 10, 20, 25 and 30. These two are merged to form an intermediate, vertex or internal vertex. See, these generally are taken as leaf nodes, and this is a created one is called internal node for us. Now again you arrange them in order, like next is 15, which is a created one, 20 leaf node, 25 is also leaf node, and 30. Then you merge them, you are going to get 35, which is a created node. Then again arrange them, so that is 25, 30 and 35. See, when you write it in circle, it is an internal node search. So towards the end, we will construct the entire tree at a time. Okay. So generally, these trees are called extended binary trees. That logic we are going to use here, right? Then these two are merged to form what is known as an internal vertex 55. Now 35 is smaller, created one 55. Now these 35 and 55 are merged to form the final one, which is nothing but, I'll just show you complete tree now. 35 here, 55 here. They are merged to form 90. So 35 is created with internal node 15 and leaf node 20. Whereas 55 is created with both leaf nodes 25 and 30. And 15 is created with leaf nodes 5 and 10, my dear friends. Now, if they ask the question, minimum number of record moves or minimum record moves or minimum moves simply, what you need to do is just take all internal node sums. You will get the answer. 90 plus 35 plus 15 plus 55. Yeah, you can do the file length multiplied with depth of the file. With that also you can get it, which is nothing but 195, my dear friends. There is one more question which is possible here. They can ask you, what is that they can ask you? Number of comparisons. How many comparisons required? This is one more question which may ask. Please answer that question. How many comparisons required? What is the minimum number of comparisons required, my dear friends? What is the minimum number of comparisons required? Please answer that question. Yes. So for that you need to do total moves minus number of internal nodes. Just do this. You are going to get the required answer, which is 195 minus how many internal nodes? 4 nodes, which will give you answer. See, here some people already verifying their knowledge. There may be some people, who are learning certain concepts. So that's why I may be solving the problem, my dear friends, so that it would be helpful for both the type of people. Am I clear? We cannot always concentrate on, because the marathon idea is You solve it, then I'll give the solution. Sometimes I may give better solution or bad solution. Then what you do, whatever it is, that is the procedure, my dear friends. Right? Nice. We completed this. Next one. Agla samasya. The next question, my dear friends. Find the minimum cost of merging 10 files whose lengths are given if you are only allowed to merge 3 at a time. Here you are allowed to merge 3 at a time, not 2 at a time, sir. You are allowed to merge 3 at a time. What is the answer for this? Dear friends, see, when you want to merge 3 files together, okay, it's like, 3 we are going to merge together. That is how we are going to see. First thing, what? We have to arrange them in a sorted order. First thing is we have to arrange them in a sorted order. Very good. Standard question. So people answer quickly. So first let us arrange them in the sorted order. 1, 2, then 3, then 4. 1 is done, 2 is done, 3 is done, 4 is done, then 5, then 10, then 15. But here, yes, very good, dears. Here, if you want to merge them 3 in pair, we should have that many required number of files. Suppose if you do not have that many required number of files, you can use some dummy files of length 0 in the beginning. Yes, 10 files. Acha, it is not 10. 10 I not given, huh? Oh, 1, 2, 3, 4, 5, 6. Oh, sorry. I think question was changed. No problem. Koi baat nahi. Let us solve this. Then these options, okay. Maybe different question. Then how you answered 61, sir? You people remember the answer or what? This is very bad then. This is very, very bad then. For this problem, 61 is the answer. Then, so you remember some question and you are answering for that. Okay. 61 answer is then it's fine. Then we'll keep it. Okay, we'll keep it open. Maybe not 10 files. I think I should have changed this number. Sorry for this. This was a small printing error. Crimes will happen. Crimes will happen. Now let us see. You can combine them. It will form one file. Then these 3, you can combine them. So that would be, see what happened. This is a single file. Then these 3. I think we can directly do this problem. Okay, directly we can do this problem. Yes. So first of all, 1, 2, 3 can be combined to form the internal node 6. Then we have to arrange them 4, 5, this created node, then 10 and 15. And these are combined to form 15, internal node 15. Again arrange them 10, 15 and created node 15. Now these are combined to form the final one. Yes. So the question is correct, number is wrong. This number was wrong, sir. No problem. Am I clear? This number was wrong. Sorry for that. No problem. We can do that now still. Yeah. So what happened to this? This is 25, 35. Now let us see this. This is 35, which is made up of the leaf node 10, leaf node 15 and internal node 15. Now this internal node 15 is made up of leaf node 4, leaf node 5 and internal node 6, which is made up of 1, 2 and 3. Still the answer is correct only. That is 61 is correct only, but number was wrong. This number was wrong. Sorry for that. Rest of the thing is fine about this question. Which one is 35? Oh, sorry. Sorry. 40. 40. Yeah. Right. Yeah. You are correct. Good. So that is the answer. So which is 61 manifests. Wonderful. Yes, sir. Okay. Surrendered. Hands up. Nice. Next problem. अगला समस्या. See, questions are changed, sir. Don't guess the questions, answers. So please answer this question, sir. अगला समस्या. Next problem. Yeah, both optimal merge and Huffman coding regularly they ask questions, sir. Both are very important. Both are very important. Okay, both are very important. So here I given the numbers once again. Here it would be very simple, sir, because these two fellows will be merged to form 2. See, but the created one we always keep in the right side. Let us keep that particular format. Am I clear? So this is the created one. So 1 merge to form 2. Now again when you arrange them, this 2 and the created 2, these are merged to form 4. Then 3 and this created fellow will form 7. Then 5 and this fellow 7 will create 12. Then 8 and 12 will create 20. Then 13 and 20 will create. Any mistakes, please let me know, sir. Is it lagging? See, there is a slight delay will be there. There will be a slight delay, my dear friends, obviously, because YouTube session, there will be slight delay. So you have to cope up with that. Slight delay will be there. Am I clear? So 13 and 20 will give you 33. Then finally 21 on left and 33 on right will give you 54. So when you create this particular Huffman tree, stream is fine. Very good. Thank you. So what happens? 54 is the root fellow. 54 is the root fellow. So the left subtree is the leaf node. Right subtree is having internal node 33. Whereas 33, left subtree is the leaf node 13. Whereas right subtree is internal node 20. 20 is made up of leaf node 8 and internal node 12. 12 is made up of leaf node 5 and internal node 7. 7 is made up of leaf node 3. Okay, you are getting some sound background. Is it nice music? Nice background music or bad background music? आवाज तो अच्छा नहीं है. Let us see how to remove that. Don't worry, you just continue. I'll remove the noise. Okay, I'll remove the noise. Don't worry. 4 will be 2 and 2 and 2 will be 1 and 1. Okay, we'll remove that. Don't worry. Okay. Now it's fine. Now it's fine. Now it's fine. See, generally, the one which is leaf node should be left, the internal node should be right one. That is, already existing values must be kept left, and the newly created one we keep it right. So let us follow that particular strategy, my dear friends. That is the method we are following, right? Am I clear? See, anyone you can take, that's what I am saying, but because if you say anyone, sometimes you take it left, sometimes you take it right, it would be confusion. So you have to follow that uniformity throughout. Am I clear? You have to follow that particular uniformity. Am I clear? Clear or not? Now what happens? Here you are having this is 0 and this is 1. Even here for right edge people take 0 and left edge people take 1. That is also possible. That is also can be taken. But we will follow a particular pattern. Generally we try to answer. Suppose he is expecting a different answer, we can write according to that. We can write according to that. That's it. 0 1 0 1 0 1 0 1 0 1 0 1. Now here we'll see the option which is given. What is the question? 1110 0 1 0 0 1 0 1 1 0. Now obviously you can see one pattern, if you find it, it will not be prefix of any other fellow. So obviously you can find it. 1 we don't have, 1 1 also we don't have, 111 also we don't have, but 1110 we have. 1110 is what? 5. 5 means E. It is E. Next 0 we have. 0 is H. Then 1 we don't have, but 10 we have. 10 is 13. What is 13? That is G. Then 110 we have, which is 8 means F. So that is F. So like this you can easily identify, sir. Suppose if you want to complete this, this is D, this is C, and this is B, and this is A. Sorry, that's it, B. Where is A gone? I think its last one is 1 only, na? Okay, it is leaf node only. So I think it is A and it is B. Am I clear? So this is how we can easily identify each and every. This is how we can identify each and every. I mean, what do you call that? Representation or encoded string for the each character, my dear friend. Encoded string for each character. Can you write the string for this character? Can you tell me the string for FDHEG? Can you tell me the string for FDHEG? Can you please tell me the string for FDHEG, sir? हाँ पूछते हैं, दोनों वो भी करेंगे पहले ये करने के बाद. See, the type of question they can ask you is number of bits used, average number of bits required. Number of bits required, average number of bits required. या तो he gives a string and you need to identify what is that string. These are the questions which they can generally ask you. Is the idea clear? Can you answer this? FDHEG. What is FDHEG? Okay. No one want to answer this. Anyhow, let us move on to the next problem then. If no one is interested in this, let us move on to the next problem. A message is made up entirely of characters from the set P, Q, R, S, T. The table of probabilities for each of these characters is shown below. If a message of 100 characters over X is encoded using Huffman coding, then expected length of the encoded message in bits is what? What is the expected length of the encoded message in bits, my dear friends? Story is same. So we are having this particular problem where P, okay, we can arrange them in the order, my dear friends. It's a numerical answer type, so I'll just write the information. Those who want can complete it. Okay, meanwhile, I'll just write the information and keep it ready. So I'll put it in the sorted order. So T is the smallest one, having length 0.08. After that, it is 0.17 R. After that, it is S, 0.19. P, which is 0.22. And finally, Q, which is 0.34. You please complete this, my dear friends. So again, we can combine these two fellows, 0.08, 0.17, which is 0.25. Yeah. Then what happens? This is 0.19, 0.22, 0.25, which is created one, then 0.34. Right. Then these are combined, which will give you how much, sir? 0.41, which is a created one. So again, writing them in the order 0.25, 0.34. Oh, 0.34 is a leaf node. Then 0.41. Very good. Now you can combine them. Now you can combine them, which will give you 0.59 and 0.41. Now finally these can be combined. So 0.41 is a internal node. 0.59 is an internal node. Combining them, you are going to get 1. Now 0.41 is created with the leaf nodes 0.19 and 0.22. 0.59 is created with internal node 0.25 and leaf node 0.34. 0.25 is created with, which is an internal node, created with the leaf nodes 0.08 and 0.17. Is the idea clear? Now, if you add up all this, then you are going to get number of bits required. Am I clear? You are going to get number of bits required. Okay. 0.25, 1 plus 0.41 plus 0.59 plus 0.25. What is this answer, my dear friends? What is this answer? Which is equal to 2.25 bits. So to encode these 5 characters, we require 2.25 bits to encode this. Okay, because it is a probability is given, it is not exact value is given, so you get obviously the answer also in the fractional form. So don't worry about it. Okay, so don't worry about it. It is number of bits required. You get it in the fractional form because these are not exact values. We only know the probability, so you get the answer also in the approximate. That is not exact answers you are going to get. So if you are messaging 100 characters over X, okay, encoded using Huffman coding, then the expected length of the encoded message in bits. So what is the expected length? Expected length for 100 characters. So just हाँ, just internal load plus कर दो यार. Why to unnecessarily? People always do this into multiplication. That is waste of energy. Just multiply internal loads, you will get the answer. Always you can do that. Okay? You can just multiply internal nodes, you will get the answer. Correct or not? Check, we can verify that. That is obvious formula, my dear friends. Okay? Properties. From binary properties, you can understand that. Right? So, what is the expected length for 100 characters? So, just 2.25 into 100 you have to do it, which will give you 225. So, that is the answer for this problem, sir. 225 is the answer. So, the expected length of encoded message will be 225. For 100 characters over X, the expected length. See, for X, okay, for 100 characters, the expected length over X is given by 2.25 into 100, which is 225. Straight away. Hope you understand. Clear or not? Good morning, Satya sir. See, what is that you want? What is that you want? Number of bits required. That can be calculated with that formula or this formula. Both will give you the same answer, my dear friends. Okay? Both will give you the same answer. I know that you people generally do this way. 0.19 into depth plus 0.22 into depth plus 0.08 into depth. Correct or not? This way also you do it, you will get the same answer. So when you get the same answer, why to waste energy? Right? The next problem. Consider the following job sequencing problem with 9 tasks. The number of tasks completed in the optimal schedule. How many tasks will be completed in the optimal schedule? Answer this question. How many tasks completed in the optimal schedule, my dear friends? Eight will be completed. Ayesh Thakur. Is it 8? Yeah, job sequencing with deadlines. B. So here we need to arrange these jobs according to their profits. Which one is having highest profit, sir? So we'll write the numbers. Which one is having highest profit, Babu? 30 is the highest profit. Next highest profit is 25. Next highest profit is 23. Next highest profit is 3 is done, 33, then 20 only, 20, that is 4. After that, 18 two fellows are there. Both can give you 5 and 5 or 5 and 6 you can give. Then it is 7. Then it is 8 and it is 9. हाँ, आंसर्स याद करके मत जाओ यार, ऐसा नहीं करना है. I know some people remember the answers also. Okay, there used to be some workbooks. People just remember the answers of the workbooks. Am I clear? Now, you create the Gantt chart. No answer, not. So maximum 7 is there, no? So we can write 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. Any problem, sir? Right. So what happened? We start with the T3 and its deadline is 5 units. So let us check whether fifth interval is available for processing or not. It is available, so first process this here. T3 is processed here. It is done. Next one is second highest is 25 profit, whose deadline is 3. First check whether the third interval is or third slot is free or not. Third slot is free, so complete this T9 task there. So this is also completed. अभी आगे see, I started with very greedy problems. Then I'll go for, dynamic programming problem. Today I will see dynamic programming different variants also here itself. Okay. Then third one T7, second interval, it is available, you can do it. Then we have after that fourth 20 second interval. But for T2 second interval is not available, but first interval is available. See, you have to see the last possible interval. If it is not available, go for the previous one. If it is not available, go for the previous one. If nothing is available means you cannot perform that particular task. But here fourth one, it need to be done within the 2 units of time. Second unit is or second interval is not available, so try to do it in the first interval. First interval it can be done, so T2 can be done here. Done. Next after this, these two you can take any one. You can take any one. Okay. So first let us take T4. Given the order. T4 is 18 and its deadline is 3. It is not available. Am I clear? Second is also not available. First is also not available. That is T4 cannot be performed. Am I clear? Then T5, fourth interval, we are having this particular vacant slot. So T5 can be performed here. T5 can be performed. Then comes after this 5, 6 done. Seventh one, T8, seventh unit. It is available, so T8 is performed here. T8 is performed. Then we are having eighth one, that is T1, which is 7 units. Am I clear? 7 is its deadline. But seventh interval is not vacant, so try to do it in sixth interval. Yes, it can be done in sixth interval. So T1. But all the slots are filled, therefore T6 also cannot be performed. Though out of 9, only 7 can be performed, my dear friend. Only 7 can be performed. See, the type of questions is how many can be completed within the optimal schedule they can ask you, and they can also ask you what is the profit. What is the profit they can ask you, sir. Can you please tell me what is the profit now? Can you please tell me what is the profit now? Yeah, that is what asked in the examination, so I changed that question here. Hope you understand. So what is the profit? You just add up the profits possible with these fellows. That is 15 plus 20 plus 30. That is 35, 65, leave it, 75, 83, 93, 103, 106, 116, 122. Why you are saying, is it 154, sir? I doubt. Is it 154? No, right? 154 is not the profit, I think. Correct only, 154, correct answer? Why you are giving wrong answers then? $147, huh? Please tell me correct answer. Babu, This way, if you do it, it's very difficult. You have to answer quickly. You can use calculators. Virtual calculators also you can use it. Don't phone a friend for this. $147. Very good. Now next one, the fractional knapsack problem. Quickly answer, sir. See, for these problems, I don't want to take much time. We need to solve as many problems as possible. Next problem. Anyone answering? What is the profit obtained by following fractional knapsack problem? करते जाएंगे, कहाँ प्रॉब्लम होता है देख लेंगे. So we have to find profit per unit weight, my dear friends. 12 by 4. 12 by 4 is 3. 32 by 8 is 4. 40 by 1 is 40. 30 by 6 is 5. 50 by 1 is 50. So we have to arrange them according to profit per unit weight, my dear friends. Am I clear? Profit per unit weight. Okay. So this highest one. So this is the first one. First preference is for this. Second is for this. Third is for this. Fourth is this. And finally is this one. So we are having total capacity. How much, sir? What is the total capacity? 10. So initially weight is 10. Now first one. Can I use one weight, my dear friend? Complete weight of this fifth object can be taken. Yes, weight is 1. So 10 weight available. So I can take it. So 10 minus 1, 9. The remaining weight is 9, my dear friends. Remaining weight is 9. Now the next one. This one can be taken completely. That is XY can be taken completely. So I just write this, ordered 5 tuple. Just 1 second. Yeah. So now second one is this. This is also having weight 1. So complete object can be taken. That is 9 minus 1 is 8. So fifth object can be taken complete 1. Third object can be taken complete 1. After that weight available is 8 now. Now the next one is third. 6 is the weight of the object. Total capacity now is 8. 8 minus 6. 6 can be used. Total object can be taken. 8 minus 6 is 2. Am I clear? So this, which one? Fourth object. Fourth object can also be taken full. After that, this is fourth, but here it is, its weight is 8, but the capacity now available is only 2. So you can't take 8, my dear friend. So what you do, you take fraction of that. 2 by 8 you are going to take. So for this object, that is for second object, you are going to take only 2 by 8 of the object. So the remaining ones we cannot take it. So that is 0, my dear friends. That is 0, my dear friends. Now what we need to do, just multiply them to get the required answer. Multiply them to get the required answer. Am I clear? So what is the profit, my dear friends? The profit would be 0 into profit 2 by 8. that is 1 by 4 also you can write. 2 by 8 into profit, that is 32. 1 into 40. 1 into profit and 1 into profit. So just do that. 8, 40, 30 and 50. Hope you understand. So which is 128. So the required profit is 128, my dear friends. Clear? Of course, standard greedy algorithms complexities are given in this. What I do is to this particular one, anyhow this complexity discussions for greedy algorithms are beyond the scope, so we are not discussing here. But remember these complexities, sometimes match the following kind of questions they can ask you. There it would be very, very useful. Match the following kind of problems, it would be very, very useful. So please note that. Okay? N log n is the answer. Clear? Okay. Now we start with the dynamic programming. My favorite MCM. My favorite problem, MCM. Please answer this question, sir. Your 2 minutes starts now. Okay? So here, to multiply 5 matrices together, what is the answer? How many orderings are possible? The number of orderings given by, when you are having 5 matrices, it is Catalan number with value n equal to 4. C4 is the answer. When you are having n plus 1 matrices, then it is Cn is the answer. Cn is Catalan number. What is Catalan number? For those who do not know what is Catalan number, Cn is given by 1 by n plus 1, 2n Cn. Okay? So, what is it? 1 by 5, 2n. That is 8C4. Babu Nishikumar, you have to simplify and give the answer for that, na? 8 into 7 into 6 into 5 upon 4 into 3 into 2 into 1. 5 cancel, 4 2s 8, 3 2s, which is 14. So the answer for this problem is 14. So if you are having 5 matrices, without using the dynamic programming approach, if you want to do it, you have to take 14 orderings, and for every ordering you have to find how many multiplications required, and out of that the minimum you have to calculate, my dear friends. The minimum you have to calculate it. So roughly the complexity of this would be not big O, big omega. The complexity for this would be big omega by 4 power n by n power 3 by 2, my dear friends. That would be the complexity, my dear friends. If you use this particular method, direct method, that would be the complexity. So to avoid this particular complexity, what we do? We use the dynamic programming approach. By dynamic programming approach, we can speed up the complexity to order n cube, my dear friends. We can speed up. That exponential complexity can be converted to polynomial complexity. That is the idea. Oh, what is the correct answer for this? Just now I answered. Yeah, normally exponential algorithm, by this method, what happens? We can convert into polynomial. Babu, what is that n power 2.7? Are you writing Strassen matrix multiplication algorithm, Suraj Mishra? Don't get confused. It is order n cube algorithm. Matrix chain multiplication problem can be solved in order n cube time, my dear friends. Of course, you are talking about any advanced algorithm which you know, I do not know. Right? Okay, answer this question, sir. Very good. So it's about identification parade, my dear friends. Because for matrix chain multiplication, when you are having matrices from Mi to Mj, you have to break at some point. Suppose you break at Mk, then it is Mi into Mi to Mk, then Mk plus 1 to Mj. So this we can write it as Cik plus Ck plus 1 J, my dear friends. Then what happens? Here you are going to get Ri minus 1 by Rk matrix. Here you are going to get Rk by Rj matrix. You have to multiply them. That requires Ri minus 1 into Rk into Rj multiplications, my dear friends. So that will give you the total formula for matrix chain multiplication. That will give you the total formula for matrix chain multiplication, my dear friends. Hope you understand. Hope you understand. That is the idea. So the correct answer is C here. So one should always know the formula, my dear friends. Try these problems. Now let us solve this problem. See, if you are having, 5 matrices, the full problem may not be given, but they may ask you the missing terms like this. This type of questions may be asked, my dear friends. Okay? So be ready for that. So I just given, you have to find the missing fellows. How to find this and how to find this. See, I think matrix chain multiplication is the problem which I taken more number of times. Okay, more number of sessions. Okay, next problem is full problem. So there you just see once. Here I'll give you quickly. But next problem, multiplication of 4 matrices, I'll tell you. Quickly follow that. Am I clear? Don't mix and match. You can easily solve it. I'll give you the method. This is a very simple method for solving matrix chain multiplication instead of multiplying matrices. Okay. So here carefully. I'll give you the procedure for this. Whenever you want to find any missing fellow here, you travel left till you get 0. This is 0 you got now. So that fellow plus the fellow immediately below this number. Then next number and the number below this. They will be added. So to get this is actually M24. So if you want to get M24, what you actually do is, you have to take minimum of 2 numbers. For that, this trick you can use it always. Travel left till you get 0. That fellow, last fellow, that is the 0 fellow, the immediate bottom fellow. You travel left, you travel right, you travel down. That is next fellow plus next fellow. So what you are doing, see the ticks 0 and 72 are added. And the stars, that is 90 and 0 are added. Now actually, you need to keep this, orders actually. You generally start with R0. So R0, R1, R2, R3, R4. Okay. So it is 4, 5, 3, 4, 5, 3, 6, 4 and 5, because it is 5 matrices, na? 5. See, when you want R24, when you want M24, what you need to do is 1 less than 2, that is 1, 4 you have to fix. 1 and 4 you have to fix. This 5 and 4 are fixed, that is 5 into 4 is fixed. Now the K values are intermediate fellows. This is ones and this is ones. That is K is 2 or K is 3. K is 2 or K is 3 you are going to use. So this is how we are going to get that particular answer, my dear friends. So now it is 72 plus, here it is 60, sorry 5 4s 20, 23 60, 60 into 72, this is 132. And here if you do it, it is actually 20, 120 plus 90, 210. So it is more. So this is the smallest value. So what is the smallest value, sir? 132. 132 is the answer. Hope you understand. Clear to you all. Now the next one, if you want to find the final answer, that is M15. See here carefully. For M15, how you go? Okay, this matrix multiplication is the problem which was asked many number of times in GATE examination, and I always see people doing it with multiplication of matrices method, or M24 means what they do, that M24 this multiplications, that okay, that all can be done, but you know, if you don't apply the procedure, what is the use? And for that I am saying, if you are here leftmost fellow, that is 0, see here one fellow will be available in the row, one fellow will be available in the column. So the row element plus column element sum, you are going to do it. Okay. So which two elements you are selecting, sir? This fellow and this fellow plus this fellow and this fellow. I put the ticks and stars, I put it for simplicity purpose. So that 0 and 72 are added, 90 and 0 are added. Then you are doing M24, no? So here you keep these values R0 to R5. When you are finding M24, just move left side I value 1 left. That is when it is M24 na, you start with 1 and 4. That is R1 and R4 you fix. R1 is 5, that is fixed. R4 is fixed. These two are fixed. Now the corresponding value of K is the intermediate lead. You will find two K values. That is two values you can find in between R1 and R4. You take them one after the other. That is, first you take this 3 that you put it here. Then you take this 6 value and that you put it here. It will take care of your formula, sir. I am just doing the formula business only, nothing special. Okay, the formula is Ri minus 1 into Rk into Rj. So Ri minus 1 means when it is 2, I am just taking 1 less than that. I am taking 1 less than that. Rj is fixed, right side fellow fixed. K varies from where to where? K varies from I to j minus 1. So that is it. These two values I am taking it. The formula is taken care automatically, sir. With observation I am telling you. With observation I am solving the problem. So now what is the answer for this, sir? This is 132, whereas it is more than 132, so you can ignore. So the answer is 132. Now similarly here also, here if you want to find this, 0 plus 207, next 60 plus 132, next 132 plus 120, next 180 plus 0. See, I am putting symbols so that you can understand these two fellows we need to add. I am keeping same symbols so that you can understand these two fellows you need to add. Okay, how you remember your wish, sir? Or you have to remember with the formula. You have to remember with the formula. Got it? Now here also when you are finding M15 means R0 and R5 you are going to fix. That is 4 and 5 you are going to fix. 4 and 5 are fixed. 4 and 5 are fixed. The intermediate K value, once it is 5, once it is 3, once it is 6, once it is 4. Right. Yes, Vishishta Chagi, you are perfectly correct. 252 is the correct answer. 252 is the answer. Which one is going to give you the 252, sir? Which one is going to give you the 252? I think second one is going to give you 252. Remaining all more than 252, so the answer is 250. So the correct answer for this is option B, 132 and 252. Hope you understand. Is the idea clear, Babu? All of you able to follow? Now we can solve this problem. Consider the 4 matrices with their dimensions 5 by 10, 10 by 3, 3 by 12 and 12 by 5. Minimum number of scalar multiplications required by the matrix chain multiplication algorithm. And here also complete problem hardly take, if you use this technique which I given, it hardly take any time for you, sir. See, what you need to do is initially you have to write this R0, R1, R2, R3, R4. That is 5, 10, 3, 12 and 5. Because first one is 5 by 10, next one is 10 by 3, next one is 3 by 12, then it is 12 by 5. So that R0, R1, R2, R3, R4 values, you keep it ready. Now I can fill this table within no time, sir. We can fill this table within no time, my dear friends. We start filling with the main diagonals. Next time what you do is, this R0 to R4 values are there, no? First 3 you multiply, next 3 you multiply, next 3 you multiply. Then you are going to get these values, sir. 5 into 10 into 3, that is 150 here. Next 3 you multiply, 30 into 12, 360. Next 3 you multiply. 12 3s, 36, 36 5s, 180. And here you can also say what is the matrix where you are going to break it. हमेशा ऊपर ही स्टोर करेंगे तो क्या ऊपर स्टोर करेंगे? कौन सा ऊपर स्टोर करेंगे यार? निशु कुमार, what is that you are asking? I didn't get you. आप क्या पूछ रहे हो, मुझे समझ में नहीं आ रहा है। कौन सा ऊपर स्टोर करने की बात कर रहे हैं आप? हाँ, टेबल में मेन डायगोनल के ऊपर. There are different approaches, sir. I am using a simplest possible approach, which is easy to remember also. Some people use this type of table also. ये table भी use करते हैं इसका. They are all different nonsense possible, sir. Diagonal और उसके ऊपर. See, once you understand na, that way you can remember. That's the idea. Narendra Kumar says C is the answer. Wow, let us see. 180 is the answer for this, sir. Guessing, Narendra Kumar Babu. Guessing is a dangerous job. Yeah. See, first thing I told you now, what you need to do? First thing, what you need to do? This R0, R1, R2, R3, R4 values are there. No, first 3 you multiply, next 3 you multiply, next 3 you multiply. Got it? See, actually what happens when it is 1, 2, you have to 0, 2, intermediate only one fellow will be there. So that is these 3 fellows only directly. That is direct idea, my dear friends. That is direct idea, my dear friends. Now, once you done it, the next diagonal. For filling next diagonal, I told you na, 0 plus 360, 150 plus 0. This plus this and this plus this. So, you are going to write 0 plus 150, 0 plus 150. If you want, you can just write M13. M13 is equal to 0 plus 150. The other one is, 0 plus 360. I am very sorry. 0 plus 360 या तो 150 plus 0. Now in this what happens? R0, R2, R0, R3, because M13 no, R0, R3 fixed. That is 5 and 12 are fixed. 5 and 12 are fixed. The intermediate fellow can be either 10 या तो 3. This is 10 here and here it is 3. So what is the simple answer or smallest answer out of these two? Out of these two, which one is smallest? So this is 12, 560, 180, 180 plus 150, 330. This is 330. Obviously it is smaller. So we are going to use 330. And because you are taking second value of K, K value will be 2 here. K value will be taken as 2 here. Next one is M24. For M24, what you are going to do? If you want to find it, this plus this, that is 0 plus 180. Ya to this plus this, which is 360 plus 0. Now here, when you are having 2, 4 means 1 and 4 are fixed. That is 1, 4 are fixed. That is 10 into 5 is fixed. The intermediate fellow will be either 3 ya to 12. Either 3 ya to 12. Am I clear? Hope you understand. So now it is 150 plus 180, which is 330, which is smaller. So we select this 330. And here, which K value you are selected, sir? Which K value you selected? Because K2 you selected. K2 you selected. And finally, you want to find this M14. M14 क्या होगा? Minimum of. So you are here. Wonderful, Aryan Kaurav, super. 0 plus 330. 150 plus 180. Next 330 plus 0. Then what happens? R0, R4 will be fixed. That is 5 into 5 will be fixed. Correct or not? 5 into 5 will be fixed here. Always 5 into 5 will be fixed. The intermediate fellow can be either 10, या 3, या 12. Out of that, what is the smallest one? You have to find it. Say I'm telling you now, when it is 4 matrices, yeah, 5 matrices, that also can be hardly done within 5 minutes, sir. Everything, if you understand the pattern, see, generally people say, oh, it will take more, it will not take more time, sir. If you do observation, hardly it takes any time. People are already giving answers. Okay? You can give answer for any problem like this, my dear friends. So, what is the smallest out of this? It is 2, okay, 25 times 250. It is more. It is 25, 250. I think it is 25, 375. 150, 330, 75. 405. This is the smallest one. And here K, we are selecting K2 here. K2 we are selecting. 405 is the answer. 405 is the answer. See, I used the matrix chain multiplication formula, but I have not written the formula. That is the idea here. Am I clear? We are using the logic of matrix chain multiplication only. With that only we solved it. That we just made it as an observation, sir. We just made it as an observation. That's it. So if you see this, where to cut this also, we can understand M1, M2, M3, M4. I've been trying to tell you that this is the best concept from almost, I think I taken 4 sessions in YouTube itself. I've been telling this from the beginning. Unfortunately, okay, you need to take time for marathon. That is 1 month before marathon, people are understanding this idea. So this much time people are taking to understand a concept which is available freely on internet, right? Almost I think 4-5 months, 3-4 times I did this matrix chain multiplication only. See, dynamic programming is the one which most of the people ignore it, but that is the easiest topic out of all. See, you can see I done this in the previous crash course also. I done it. Okay, and recently there was 3 years, last 5 years GATE questions I done it. Last 5 years GATE questions I done it. Earlier I done one course like how to think recursively. In that also I discussed it. Many times I discussed the same problem in the class itself. Okay, now many people are saying it's a best concept. I know it's a best idea, best observation, but unfortunately people need to fix that. Okay, of course, apna time aayega. Every problem will get that time so that people understand the best method for that at some time. Now M1 to M4 you are having, you cut at 2. So obviously you are cutting at 2. That is break is done at 2. So once you break it here, obviously M2, M4. That's it. There also I given this idea, my dear friends. There also I given this idea. But at that time I know that, because examination fear is not there. So people go very leisurely. Now I think this is the time where most of the people understand this logic, these ideas, and they implement them properly. Use this methodology, this observation method which I am giving you. Even if it is this matrix also, you can do within no time. Okay? Even this problem you can do within no time, my dear friends. Next problem. We are given 2 sequences x and y of length m and n respectively with indexes of x and y starting from 1. We wish to find the length of longest common subsequences, length of longest common subsequence LCS of x and y as LMN. Let Lij be length of LCS of the first I characters from x and j characters from j. Then what is the missing terms in this, my dear friends? There can be multiple answers correct. You have to identify them. All of you know LCS problem. You want me to explain this recurrence formula? Because I am very much interested in the recurrences, my dear friends. Okay. See, I always see people by heart the recurrence formula. Even for matrix chain multiplication, recurrences can be derived, my dear friends. Okay. Because we derive recurrences in discrete mathematics. Here also. See, the idea for LCS is this. The longest common subsequence problem, the idea is this, sir. We are having sequence 1 to n or m? M, okay. And y is having length 1 to n. Okay. So, we actually need the LMN. That is, first sequence x is having how many letters, sir? M letters it is having. Y is having n letters. That is, x is a string of length m and y is a string of length n. And you want to find the longest common subsequence. We want to find longest common subsequence. Okay, for those who have trouble with this sequence idea, let me tell you. Suppose if you are having computer, you can remove one or more symbols from anywhere. You can remove symbols from the beginning, at the end or middle. Whatever is obtained is called subsequence. So here, by removing C, O, P, R, you can get mute. This is a subsequence. So mute is a subsequence of computer. But it is not a substring. Substring is different. For substring, you can either remove the symbols from the beginning or end or both, but not somewhere from the between. That cannot be done for substring. It is not substring, sir. It is subsequence. You can remove symbols from anywhere. That is the story. Now, I want to find the length of longest common subsequence. For example, look at these two sequences. Here it is ABCA and here it is ABBA. What is the longest common subsequence? Longest common subsequence in these two sequences. Longest common subsequence. You see ABA here and you see ABA here. That ABA is the longest common subsequence which is available in both. We need to find that. Yeah. So that is the idea for this length of longest common subsequence. So to solve this, we are going to create a recurrence relation for intermediate problem. So we consider string from 1 to I here and y string from 1 to j we consider. Like 1, 2, 3 up to ith symbol. Here up to jth symbol you are going to consider. Now here one thing will happen. When you are considering these two strings, for example, if you consider these two strings, ABCA, ABBA, like this if you are considering, suppose it is 1 to I and it is say 1 to j, sir. They need not be of same length, sir. See, one thing which can happen is the last symbols may match or may not match. Correct or not? The last symbols may match or may not match. Correct or not? So if the last symbols matches, that is xi equal to yj, then what happens? If it matches, then what happens? So already one match is there. So in the remaining sub problem, how many matches you are going to get? That plus 1 will be the answer. So if there is a match between xi and yj, the remaining subsequence, suppose you call this as Lij problem. If there is a match of xi and xj, the remaining sub problem will be Li minus 1, j minus 1. That is x 1 to I minus 1 and y 1 to j minus 1 sub problems you find longest common subsequence. That plus, because already match is there, plus 1 will be the answer. So this plus 1 will be the answer if there is a match. Correct or not? If there is a match, then that is the answer. Now suppose if these two are not matching, sir. Xi is not matching with Yj. Now see this carefully. I will show you two parts here. Xi is not matching with Yj. There are two possibilities. I will show you two possibilities. See carefully. See, in this particular case, what can happen is, this is 1, I minus 1, I, Y, 1, J minus 1, J. Again I write it, X, 1, I minus 1, I, Y, 1, J minus 1, J. See, in this particular situation, what happens? See carefully. In this particular situation, what happens? See carefully. Now look here. Suppose if these two are not matching, you can't take I minus 1, J minus 1, sir, because this ith symbol may matching with J minus 1. So what we do is, either you consider this sub problem or you consider this sub problem. Correct or not? Because if these two symbols are matching, we don't have to waste energy. Either one I symbol can be ignored or J symbol can be ignored. Here J symbol is ignored. That means you are finding length of longest common subsequence for Lij minus 1. Here what you are finding? Length of longest common subsequence for Li minus 1 J, my dear friends. But I don't know which one is better. So maximum of these two fellows will be the answer. Maximum of these two fellows will be the answer. Lij minus 1 and it is Li minus 1 J. That would be the answer, my dear friends. That would be the answer. Hope you understand. Maximum of these two you have to take, because you don't know which one is better. So maximum of those two we have to take it. So what is the answer for this problem, Babu? What is the answer for this problem? This is correct for expression 1 and this is correct for expression 2. A, B correct answer. Very good, Saurav, Aryan Kaurav, Vishishta Tyagi, Vitishta Tyagi. Very good, very good, very good. Now the table is given almost, but some numbers are missing. You have to fill that. So people have this particular problem. Fill table completely fill karna hai. See, without understanding recurrence dynamic programming करे तो feel नहीं आएगा. Recurrence समझना है, then dynamic programming का energy अलग level में होता है. I'll show you some C programming questions which were asked, which can be solved by dynamic programming approach now. I'll take few C programming problems for which we write tree diagrams and solve now. They can be solved using dynamic programming approach. The very idea of dynamic programming, let us try to use. See, my dear friends, for those who do not know the procedure, let me quickly give you. Whenever two sequences are given with LCS procedure, if you want to solve it, okay. See here 1, 2, 3, 4, 5, 6. This is the Y fellow. This is X fellow. This is Y fellow. We start with 0. 0 has nothing to do, 0 length. Why zero length? The first symbol. What is the first symbol here? P. Second symbol Q. Third symbol R. Fourth symbol S. Fifth symbol S. Sixth symbol P. Seventh symbol Q here. What about Y? First symbol Q. Second symbol S. Third symbol R. Fourth symbol P. Q and P. Very good, Nishu. Super. So here what you do, sir, firstly it is when it is zero length, matching will not be there. Zero, no matching will be there. But here what happens? Whenever there is a match, see when you move here, it is actually start from here. When there is no match, left ya top fellow, whatever is maximum, you have to write it. If both are same, anyone you can write it, my dear friends. And you generally keep these arrows. You generally keep these arrows to know this value is coming from where, because that will help you in identifying the longest common subsequence also. That will help you in identifying longest common subsequence also. Hi Neeraj Kumar. Hello sir. Now here also P and S no matching. No matching. So it is coming from either top or bottom. Both are same. Not matching, top or bottom. Matching. See when it is matching, see you remember Li minus 1, J minus 1 plus 1. You remember this. What we done? When it is matching, Li minus 1, J minus 1. So for this element, the diagonal fellow will be Li minus 1, J minus 1. For that, whatever is there, you just add for that. Add 1 to this. So to this, you just add 1, you are going to get this. So whenever it is matching, now this fellow and this fellow matching, this answer is diagonal value plus 1. Now again PQ not matching. P here, Q not matching. So whatever highest is there, that value you take it. PP matching. Matching means don't add, sir. Again diagonally what is there? That fellow, to that you add 1, my dear friend. To that fellow you add 1, my dear friends. So this is how this particular table is created. Now when you want to find this particular value, you see S here and you see Q here. Not matching. Not matching means either this value or this value. That is 2. A value will be 2. So the value of A is 2 here, my dear friends. Value of A is 2 here. Now if you want to know B, P here and P here, matching. Matching means diagonal value plus 1. So this value will be 3. So the value of B is 3. Now C, here Q and here P not matching. So out of these two, what is highest? 4 is highest. So C value is 4, my dear friends. C value is 4. So this is how we can get this table. If you want, you can complete this table in the same manner, my dear friends. And you can trace back to get the required answer also. You can trace back to get the required answer also, my dear friends. Okay. Hopefully it is simple for all of you. So it is 2, it was 3, it was 4. But you should know from where you are getting this. Further, it is always better to write it as P, Q, R, SS, PQ. And it is QSR, PQP. Right? So now, if you want to see what is the longest common subsequence, you can see from here, we can create that particular fellow. Because 4 is coming because of that. So we have to move. See, when you are coming by, the arrow from left, arrow from top means there is no matching. So just either you can go to top arrow or left arrow. So here, you just go here. But here 4, there is a matching. You see Q and Q, there is a matching. So you have to travel to the diagonal fellow. But here what we need to write? Because when there is a matching now, the matching symbol you write down and move diagonally up. Move diagonally up. You are here. Now here there is a matching. Yes. So you move diagonally up here. You move diagonally up here. So write this symbol and move diagonally up. Now here S and R not matching. So here we are having 2 arrows. You can go this direction or you can go top direction also. two different substrings you are going to get, sir. It's not just one, two different substrings you are going to get here. Suppose let us go here. Again, S and S matching. Matching means diagonally write the symbol and move diagonally up. S and Q not matching because one is coming from here, so move up. RQ not matching, move up. Q and Q matching, so write the symbol and move diagonally up. Once it is 0, you can stop there. So the answer QSPQ is the longest common subsequence. There can be one more also because here I moved this direction, so I got this. But if you move this direction, you get another answer also. PQ here now, suppose if you move here, there is no matching. So again there are two more possibilities are there. Suppose if you move this direction, one answer. If you move this direction, one more answer will be coming. Am I clear? There may be multiple longest common subsequences possible here. Hope you understand. Hope you understand, my dear friends. Yes, second one also can be there because you are reaching, you are here because of this, this. Both are same, na? So if you move this direction, you may get one longest common subsequence. If you move up, you may get another longest common subsequence. Hope you understand. Clear? Of course, he asks what is the same problem. What is length of longest common subsequence? What is length of longest common subsequence, my dear friends? Four we already solved. No? 4 is the length of longest common subsequence. C value is the answer. C value is the answer. See, generally we solve this problem using C programming, but this can be solved with a dynamic programming approach. What is the answer for this problem, my dear friends? What is fun phi? We are having this particular recurrence relation. What happened? People are not responding. See, my dear friends, here if you see fun n minus 1, fun n minus 2, that is a formula actually here. It is fun n is equal to 2 times fun n minus 1 plus 3 times fun n minus 2. Please answer the question, Babu. The base condition fun 0 is equal to, so let me create the table. Let me create the table for fun. N value and fun value. For n is equal to 0, it is 1. For n is equal to 1, it is 1. For n is equal to 2, what is it? See, always previous fellow into 3 and the next previous fellow into 2. That is, if you want to find this, 2 into 1 plus 3 into 1, which is nothing but 5. And if you want to find this fellow, previous number into 3, previous but previous number into 2. That is 2 into 1 plus 3 into 5, which is nothing but 15 plus 2, 17. Suppose if you want to find 4, what is it? 5 into 2 plus 17 into 3. 51 plus 10, 61. If you want to find 5, what is it? 17 into 2 plus 61 into 3. And that would be the required answer. So with tabular form, I could able to answer this within no time, my dear friends. With tabular form, you could able to answer it. You are not substituting and solving, sir. I am just using the previous values tabulated, store the values and reuse the values. That is actual idea of dynamic programming, my dear friends. Store and reuse is the main philosophy of dynamic programming. See, when I teach C programming, I teach by that method only. But I'll give you the idea for that there. Now look here. Fun n is 2 into fun n minus 1 plus 3 into fun. I think I made some mistake, might be. Let me cover it again, okay? Anyhow, n value, fun value. See, for 0 and 1, it is fixed. Now for F2, if you want, whenever you want Fn, what is it? 2 times Fn minus 1 plus 3 times Fn minus 2. So previous fellow into 2 and previous but previous fellow into 3. That is this fellow into 2 and the previous fellow into 3. That is 3 into 1, which is 5 here. Now if you want 3 here, previous fellow, that is this 2 into 5 plus 3 into 1. I made a mistake actually. I taken it as Fn minus 2 and I taken it as Fn minus 1. Please be careful. If you take wrong question wrongly, everything will go wrong. Okay. So previous fellow, that is Fn minus 1, that is 2 and F1 you are going. Previous and next one. Okay. So 2 into 5, 10, 3 into 1, 3. 13 is the answer here. Is the idea clear? Next, what about F4? 2 3s, 2 13s, and what is it? 3 5s. What is the answer? 26 plus 15. 43, yeah? Right? 41, sorry, 41. I'm doing what? 41. Next one is 2 into 41 plus 3 into 13. So 41, 2's 82, 39, 11, 12. Oh, I think none is matching. Sorry, because I think I taken Fn minus 2, Fn minus 1, sir. Because of that, that particular thing is mismatching actually. Okay. This question was wrongly taken. Because of that mismatching. That's what in my mind also. So I was solving in that way only. Am I clear, sir? Actually, in my mind, it was like, 3 into Fn minus 1 plus 2 into Fn minus 2. So with that only I created this solution. Okay, if you want these answers, these options are for here 3 and here you 2 you put, then you get one of the correct answer here. Okay, so you understand this idea? Because this was created with this frame of mind, sir. Because of that you got different answer. It is a different problem, I'm sorry. So here what is the answer, sir? 121 is the answer for the given problem. So sorry for that, sir. Okay, because in my mind the question was different. So maybe I taken question wrongly, I don't remember exactly. But If you want to get these options, you have to take 3 here and 2 here. Then B answer. Okay, we do one thing, sir. You understand the logic, na? Let me remove this. Put 3 here and put 2 here and solve it. Then you will get same way. Put 3 here and 2 here, then one of the answers will match. Try this you. Okay, all of you please try this problem. All of you please try this. See, that's what we have to read the question carefully, sir. Otherwise, what happens? This kind of mistakes may happen. Please be careful. 217 is the answer. Is that 217 is the answer? Hope you all understand, right? The tabular method you all understood, right? N and fun value here. See, the tabular method is the basic idea of dynamic programming. Whenever you have excessive recursion, whenever you have such excessive recursion, use dynamic programming. It will help you solving problem faster. 0 and 1, it is 1. Now here previous 1 into 3, 3 into 1 plus 2 into 1, which is 5. For this, previous 1 into 3, that is 3 into 5 plus 2 into 1, that is 17. For 4, previous 1 into 3, that is 3 into 17 plus 2 into 5, 51 plus 1, 61. And finally 5 means 3 into 61 plus 2 into 17, which is 217. So the correct answer is C. Yes, sir. Hope you understand, Babu. Is the idea clear? All of you able to follow? Another dynamic programming problem. X of x5 is what? What is x of x5? Solve by dynamic programming approach. Solve by dynamic programming approach. Of course, I know the recursion tree methods, but use dynamic program. Means start with, here it is bottom up approach. Dynamic programming is always bottom up approach. We have to start with base values that we have to store and reuse them. Store those values and reuse them. That is the logic for dynamic programming. Fibonacci sequence. You know Fibonacci sequence 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 5 plus 3, 8. Like that you are going to get previous 2. If you add, you get this answer. That is the dynamic programming approach for Fibonacci sequence. Here also n less than 3 it is 1. So you can start n values, xn values. 0 it is 1, 1 it is 1, 2 it is 1. Now 3 onwards. From 3 onwards what is it? Previous one xn minus 2. That is previous one ignored and the next one. That is this plus next of next. These two fellows plus 1. That is 1 plus 1 plus 1, which is 3. 4 means previous fellow ignore 1 plus 1 plus 1, which is nothing but 5. 5 means what? x5 means what, sir? Previous fellow ignore 1 plus 1 plus 1, which is 7. That is x5 is 7. So you got x5, which is 7. x5 is 7. So you need x7. x7 means 6. 6 means 7 plus 3 plus 1, which is nothing but 11. 7 means what, sir? 11 plus 5 plus 1, which is 70. The dynamic programming approach. All of you able to follow? Clear to you all? This is a problem. Generally, we do it in discrete mathematics. Even this problem I solved number of times, but as I know that many people will be concentrating now more, they understand the procedures now better. The number of 4-digit numbers having their digits in non-decreasing order. Non-decreasing means increasing order only, equal fellows together, from left to right, constructed by using the digits belonging to the set 1, 2, 3. Of course, normal approach you might be knowing. So let me explain the dynamic programming approach here. You are making a 4-digit number using 3 digits only. So you can use 1 या 2 या 3 as the starting number. Correct or not? जब तक आप बैठेंगे, चलो यार, अभी हो गया डायनेमिक प्रोग्रामिंग, खत्म कर लेंगे एक दो प्रॉब्लम्स में, फिर we'll move on to ग्राफ एल्गोरिथम्स. ओके, सो जो टॉपिक्स बोला था ना, वो MST का प्रॉब्लम्स करेंगे, डिक्स्ट्रास एल्गोरिथम और बेलमैन-फोर्ड का प्रॉब्लम्स कर लेंगे. देन we can call it a day. Hope you understand. So, how many digit number? What is the starting number? So, this plays very important role. So, if I use Cij as, it is starting with I, j digit number. If I use this logic, you can get this answer very quickly, my dear friends. Because this I value which it is starting with can be either 1, 2 or 3 only. It can be 1-digit number, or it can be 2-digit number, yeah, it can be 3-digit number, yeah, it can be 4-digit number. Now starting with 1 and 1-digit number, only 1 will be there. Starting with 2, 1-digit number, only 1 will be there. Starting with 3, 1-digit number, only 1 will be there. Because it is increasing, we start with large number. Starting with 3, 2-digit number. See, starting with 3, 2-digit number means, starting with 3, what should be the next digit, sir? The next digit should be starting with 3, 1-digit number. Because the next digit cannot be less than this. The next digit should be either 3 or more than that. More than is not there. So it is starting with 3 plus starting with 3, 1-digit number. So starting with 3, 1-digit number is this. So just this answer will get it here. But when it is starting with 2, 2-digit number means the 1-digit number can be either 2 ya to 3. So that is, you just need to add these two fellows. 1 plus 1, you have to add 2. You will get the answer 2. Now if it is 1-digit number, starting with 1, sorry, not 1-digit number, starting with 1, 2-digit number means the second fellow can be 1, starting with 1, 1-digit number, starting with 2, 1-digit number, starting with 3, 1-digit number. That is sum of these three fellows. 1 plus 1 plus 1, which is 3. Now when you go for 3-digit number, starting with 3, 3-digit number means the previous numbers must be 3, 3 only. So only this answer will get it. But when it is starting with 2, 3-digit number means the next 2 digits, first digit is 2, the next can be starting with 2, 2-digit number, yeah, starting with 3, 2-digit number. That is this fellow plus this fellow, 2 plus 1, which is 3. And similarly, what is this, my dear friend? Starting with 1, 3-digit number means, starting with 1, 3-digit number means, starting with 1, 2-digit number, starting with 2, 2-digit number, starting with 3, 2-digit number. That is sum of these three fellows. 3 plus 2 plus 1, which is 6. Now here, starting with 3, 4-digit number, starting with 3, 4-digit number means, starting with 3, 4-digit number only you can take. That is only this one you can take it. But when you take starting with 2, 4-digit number means, starting with 2, 3-digit number, yeah, starting with 3, 2-digit number. Sorry, 3-digit number. So that is either this plus this. That is 3 plus 1, which is 4. Now what about this one, my dear friends? Same story we can do it. 1 to 10 means these numbers will be big, sir. because this simple, it is not that simple, my dear friends. It's not that simple. Okay, I'll just show you simple idea for that. I'll give you the recurrence formula, you try that. Now what about this, sir? This is what? 6 plus 3 plus 1, that is 10. So sum of these fellows will be 15. See here, what you need to understand is this Cij is equal to starting with I, starting with K. Let us take it as some K. J minus 1 digit number where K can be I, or it can be I plus 1 or I plus 2 up to maximum digits given. In our problem, it can be 3 only. It can be 3. Now, Mr. Nishu Kumar says, this set is 1 to 10. Then it is like this. With the same formula, how can you give 10, sir? How can 10 be given, sir? Digits can be 1 to 9 only, na? Maximum we can give up to 9 only, Nishu. First of all, let us see 9. So these are the set values. So this is I and this is J. 1 digit number means you start, all these fellows will be 1, 1, 1, 1, 1, 1, 1. 2 digit number means 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 digit number means 1, 3, 3 plus 3, 6, 10, 15, 21, 21 plus 7, 28, 28 plus 8, 36, 36 line, 45. 4 digit number means 1, 4, 10, 20, 35, 56, 76, 84, 84, 90, 120, 165. Add them, you will get the required answer, Mr. Nishu. You will get this answer. This is the answer for this. See, if you understand the logic, that simple it is. Bas. That's it. This is a formula. So here it will be 9. If you write 9, it will be 9 in your case. So please try this as homework, sir. Same logic. Using dynamic programming approach, solve it. Using dynamic programming approach, solve it. And I request those who complete the answer, write it in comment session. Okay? Comment session. DP homework 1. Using that, you can answer the question, my dear friends. Clear? Now the next one is one more greedy problem. Actually, it is a combination of both greedy and knapsack problem. Actually, it says the knapsack problem is solved both using greedy as well as dynamic programming approach. He's asking you to find optimal value. That is, optimal means the value found using dynamic programming approach minus greedy method. What is the answer he's asking? I think you can answer this. There is a very simple procedure. 0-1 knapsack is dynamic programming because greedy method does not guarantee solution for 0-1 knapsack problem. Because greedy method may not always guarantee the solution, sir. Correctness of the solution need to be verified, but 0-1 knapsack problem, greedy cannot always provide optimal solution. So want to solve it? Shall we solve it? So here for knapsack problem, items 1, 2, 3, 4. The profit weights and profits. Weights are given. Weights are 10, 7, 4 and 2. And profits are 60, 28, 20, 24. So these are the profits and weights are given. So for knapsack, of course, there is a tabular method, but here capacity is 11 and highest weight is up to 10. So that would be a very big lengthy table it would be. So let us use a simple approach for solving this particular problem, my dear friends. So we start with 0 means nothing is selected. That is first item. First item not selected or first item selected. So when you select it, what is the profit? Profit is 60 and what is the capacity? 10 is the capacity. Okay, total capacity is 11. Next, what happened? Once it is done, acha, you all know this procedure, then I can ignore it or I quickly write the answer for this. S1 0, the situation would be 0 0 and 60 10. Now when you select the second object, what happens? When you select the second object, what happens? 0 is the cost. First one is profit, second one is weight, sir. We are using first one cost and second one is weight. 0 plus 28, that is 28 and 7 it is. If you use second one, 60 plus 28 is 88 plus, but weight is 17, sir. See, whenever you want me to repeat, tell you the procedure, sir? See, because people are answering, so I am just ignoring it. If you want, I will tell you the procedure. Shall I teach you the procedure? Okay. Let me do one thing. Profit and weight, let us write down so that for greedy approach also it would be useful. Profit and weight. Profit and weight. Actually, for 0-1 knapsack, that is dynamic programming, the ordering is not necessary, sir. Any ordering is fine. But for greedy method, profit per unit weight, highest fellow, whatever fellow is or whatever object is having highest profit per unit weight, that will be written in that is in decreasing order of that we are going to write it. Here no problem, we can write in the same order, that is 60. Profits are 60, 28, 20, 24, 10, 7, 4 and 2. Now look here, sir. Initially, starting stage, okay, the first object selected or not selected. See, you not selected anything means no profit, no weight. But first object selected. See, when I say 1 means that is selected. This fellow is selected means what happens? At 0th iteration, first object is selected, what happens? The profit will be 0 plus 60, weight would be 0 plus 10. Is the idea clear? Is the idea clear, sir? Babu, is the idea clear? Then what happens? After this, what happens? When you are not selecting second object means when the first object selection is completed without selecting it or with selecting, all the situations will come here. And when second object is not selected, what happens? You write down all these ordered pairs 0 0 and 60 10. Okay. Now, okay, final answer you are giving, very good, Nishu Kumar. What if I select the second object? For each of the combinations, you have to add the profit and weight and see what happens. S11. So 0 plus 28, that is 28, and 0 plus 7, 7 is the weight. For this, if I add this second object. For this, if I add second object, what happens? 60 plus 28, 88, and 10 plus 7, 17. But here, the capacity is 11 only. So this fellow is useless for us. Because if anything is giving you cost or capacity more than the available capacity, you can readily remove that so that you don't have to continue with that for the next iteration. Am I clear? Now after second object is also selected, what is, the situation after second object is considered is this one. 0, 0, 60, 10 and 28, 7. This is ignored, my dear friends. This is ignored. Now, what if I select the third object? This object is selected with these combinations. So, for everything, what happens? The profit plus the current profit plus new profit, current weight plus new weight. That is 0 plus 20, that is 20, 0 plus 4, that is 4. Next one is 60 plus 20, 80, and 10 plus 4, 14. Next one is 28 plus 20, 48, 7 plus 4, 11. Hope you understand. This is when you select this particular object. Now write all these together and you can remove unnecessary fellows, my dear friends. See here, there are certain things which you can ignore actually. Like, with 10, you are getting 60 property, 60 weight. Suppose if anywhere the weight is more but profit is less. That is, if Pi is less than Pj with Wi greater than Wj, that is useless or dead pair, or that is useless what a pair you are considering. So that can be cancelled, my dear friends. Those fellows can be cancelled. So here with 11 you are getting 48. Are you going to use it? No, because with 10 you are getting 60, with 11 weight you are getting 48 profit, means useless fellows. Such fellows you can remove them. Such fellows you can remove them, my dear friends. Any other such fellows you find it? Any other fellows you find it? If you find it, you can readily remove them because they are not going to give any more better solution, my dear friends. Now let us write down 0, 0, 60, 10, 28, 7, 24 and 80, 14. This is without selecting fourth object. Now with selecting fourth object, if you select the fourth object, what happens? When you select fourth object, just add that 0 plus 24, 24, 0 plus 2, 2. Next one, 60 plus 24, 84 and 10 plus 2, 12. See, this is more than the required available capacity, so you need to ignore that. Next, 28 plus 24 is 52 and 9. Next is 20 plus 24, 44 with capacity 6. Next is 80 plus 24 is 104 with capacity 16. I think even this 14, why you considered, sir? Why you taken 14 unnecessarily? This 14 was useless, na? More than capacity. This we should not taken here. Should have not taken at all here. You have to avoid unnecessary fellows. Ha ha ha. See, capacity available is 11 now. What you do with 17 capacity, sir? You'll borrow a knapsack from other thief or what? See, knapsack problem is called as, helping thief problem. So let us not do that. Got it? So like this. So ultimately in this, 12 is useless fellow. Now which one is giving highest profit out of this? Highest profit you are going to get here. Highest profit you are going to get here. So 60, 10. Now if you want to see which objects are selected and which objects are not selected, this is how we should go. Now you see 1 means fourth object selected. If it is found in 0 means that particular object is not selected. Here fourth object not selected. And you see this 6010 is in one part या 0 part of the previous iteration. 6010 is in one part या 0 part of the previous iteration. Available means it is obtained from one part या 0 part of the previous iteration. It is actually available from 0 part. That means even this fellow is not selected. And this is again obtained from 0 part of it. 0 part of the previous iteration means this part is also not selected. Only first object is selected, remaining objects are not selected. So dynamic programming, if you use it, which we call it as optimal solution, the answer is 60, my dear friends. You please verify greedy technique. The greedy technique answer will be, I am not doing it, it is homework for you. 44, I think, greedy answer. So he is asking what is V opt minus V greedy. That should be 60 minus 44, my dear friends. 44, someone answered earlier. What was the answer, sir? Greedy minus... what was the answer for greedy? 44 only, na? Please check this. Please check the answer. Yeah, final answer will be 60. Is the idea clear, Babu? You can give it, sir. I'm giving you procedure. Okay. If you are up directly like matrix and multiplication here also by looking at it, if you can answer, that's wonderful, my dear friends. You can always. Password will be given in a while. Okay. So the password is solution of this problem, algo M2 with solution of this problem. That is your password. Algo M2 with solution of this problem is password. Let me write down because it is dynamically created. I should also create it. Now you all know minimum spanning tree problem. Which procedure you like? Prims or Kruskal's? What is the answer for this? I given the big problem again so that you can happily solve it. Try both the methods. Try both the methods. So tomorrow we are going to discuss data structures. So first day linked list, arrays, stacks and queues. Second day mainly trees followed by what do you call that? Hashing need to be done today, but I do it in data structures part. Maybe hashing part I'll be doing it with trees part. Okay, maybe that binary heap also, if possible, if time permits in that. Yeah, that's what. Hashing is not done here, so let us do it with data structures part. Anyhow, I'm only doing it now, so let me do that there. Or first day we do trees and second day we do linked list, stack and queue. Heap important. Heap also we try to do together with that trees. Okay, we are priority queues also will be there, no? So all the problems combinedly we can do together. All the problems combinedly we'll do together. Okay, priority queues. Yeah, 33. 1 is the smallest. Next, there are 2's. This is 2. This is 2. This is also 2. 33 is not there. Huh? Sorry. We made a mistake again. Huh? Okay. Let me check. 2 and any 2. No 2. All 2's done. 3's. See, out of these 3's, this cannot be taken because it is going to form a cycle. But this 3 can be selected. This 3 can be selected. Let us see. This 3 can be selected. Then 4. People are changing their answers. 4, this 4 can be selected and this 4 can be selected. Both are small. After 4, 5. See, with 5, no problem because no cycle is formed. This 5 can be selected. This 6 cannot be selected because it is going to form cycle. This 6 cannot be selected. It is going to form a cycle. 6 cannot be selected. 7 can be selected because it is not going to form any cycle. 7 can be selected. After 7, there is any 8. No 8 I taken. 8 is not there. 9, can I take it? 9, but 9 will form a cycle. 9 cannot be taken. Can I take 10? Can I take 10? Because if I take 10, you are going to form a cycle, sir. You are going to form a cycle with 10 also. So 10 also cannot be taken. Can I take 11? 11 also forms a cycle. Cannot take it. Cannot take 11. First of all, check whether all number of edges we got it. We got number of edges covered. Na? See, obviously when number of edges are already done, any new edge will form a cycle. So we have to avoid them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 vertices are there. 9 edges you got it. You are done. So what is the answer? 1 plus 2, 3 plus 2, one more 2. Actually, 3 2's are selected. Then 1 3 is selected. Then 2 4's are selected. Then 2 4's are selected. Then 5 is also selected and 7 is selected. 3, 3, 6, 3, 9. So answer I think 30 na. How people are given 33? They remember old answer or not? They given old, they remember old answer. Huh? Or Prim's is giving 33. Prim's algorithm is giving 33 answer for this. Is it like that? Prim's algorithm giving 33 answer for this. Is it like that? Even a single mosquito is dangerous. No underscore. Algo M2, the answer for this problem. Luckily you reminded me. No underscores. All capital letters. All capital letters. Nishu Kumar, don't write answers in the chat. Remove your answer, please. Remove that password from chat box. See, those who are interested can come and see the video now. Am I a data entry operator to provide this booklets to the students? Okay, I prefer teaching. Okay, I don't prefer giving PDFs or notes to the students. Right? See, now, you know, in this new era, people are getting PDFs and all. I generally don't suggest taking anyone's PDF also, because your handwritten notes is the most important thing for your examination. Anything else, okay, it is just a copy of them. With copy of others, you can't score marks, my dear friends. Remember that. because that is a second copy. Second copies are always second copies. Textbook cannot be replaced with Xerox. You may use it, but it never replaces textbooks. Okay, what about Prim's algorithm? Shall we use Prim's algorithm for this? Or is it okay? All of you know, I think Prim's and Kruskal's, I think you're all expert. First rank तो कभी नहीं आएगा. Right? Rank 1 आना चाहिए. Number of distinct minimal spanning trees for weighted graph below. यार अगर आए तो बता दो, या कोई भी आज तक किसी का रैंक आया ना, किसी को पूछ लो. If anyone who got first rank who done with others notes, ऐसा एक बंदा भी है तो लेके आओ, उसके साथ हम इंटरव्यू लगाएंगे. मैं सबके सामने बोल दूंगा मैं जो बोला था वो रॉन्ग है बोल के. यू कैन प्रूव मी रॉन्ग ना. हैप्पी सिचुएशन फॉर यू ऑल्सो. You don't have to believe me. So you can have some live example possible. Maybe you get the rank like that without using your notes. Possible. Then we'll have interview with Nishu Kumar. Sir, you always used to say that with others notes we cannot get rank, but I got it. Then I say, wonderful Nishu. The number of distinct minimal spanning trees. Okay. See, exceptional तो हमेशा होता है, exceptional cases भी होते ही रहता है. See, that's what, why to think about other exceptions, Nishu? You get the rank. I want to, interview you and ask this, right? Okay, leave that unnecessary discussion. Let us concentrate on the work. What is the answer for this problem, sir? Minimum number of spanning trees. Very good question. See, my dear friends, actually, if you observe, ones are selected and no one is making any cycle. Now, after that, twos to be selected. See, this is connecting these two components. So, this 2 is compulsory. So, this is having only one choice. Now, after this, here, you cannot select these fellows at all because they form cycle. They are not possible. Now, out of these two, any one only can be selected. Both cannot be selected. So, any one. So, either this one or this one. So, two choices we are having. And out of these three, any one only we can select it, which connect this edge with this edge or this part with this part. So, any one of these three can be selected. So, here we have three possibilities. So, three possibilities. For each of the three possibilities, there is one possibility for this, and for each of that there are two possibilities for this. So, 3 into 2 3 into 1 into 2, which is 6 possible distinct spanning trees possible. A very common regular question it in GATE, my dear friends. You can see number of questions of this type in GATE examination. One more question. The graph shown below, 8 edges with distinct integer edge weights. The minimal spanning tree is of weight 36 and contains the edges AC, BC, BE, BE, sorry, not this fellow, BE, EF, BE, EF, DF. Okay. The edge weights of only those edges which are in the minimal spanning tree are given in the figure shown below. So there are edge weights for A, B, C, D and D, E are missing in this. The minimum possible sum of weights of all 8 edges of this graph. So if minimal spanning tree weight is 36, these fellows are missing. So you have to tell or you have to fill the minimum weights for these edges. Then you have to find the minimum cost of the graph. You have to give the minimum cost of the graph for which minimal spanning tree is having weight 36. That is the question. So for data structuring, shall we do first binary trees topic, then followed by the next topic. First day binary trees 69. Very good, Kostu. Arrays and binary trees, because arrays basic ideas we can do it. Then binary trees will complete it. In the second day we'll do linked list, stack application, queue applications. But there may be some part which may require some stack and queue ideas. But general idea if you have, you can solve the problems. I think that is fine. Because anyhow we are doing revision. No? Because binary tree properties and all, most of the people are having some trouble. So let us deal with that in the first day. Mostly data structures. First day will concentrate on this arrays and trees and whatever we can do on that particular day. Hashing also in the first day or the second day. Okay. Definitely, because binary heaps also I try to complete it. Once it is done, okay, then hashing if possible. Otherwise next day linked list, stack, queues, because not much to do in linked list, because linked list, stack and stack applications will be more. Am I clear? Those problems we can do it. There we can do some problems on hashing and all. Let us see. I'll plan accordingly. Right. See here actually, because this is a cycle, this has to be more than 4 and 6 and the minimum value which is 7. And here 15 to 7, it has to be more than this. Therefore, this cannot be included. That is 16. It has to be more than this. That is 10 should be this value. Am I clear? Is it? Which one is 11? ED 11. ED 11 and because it's a cycle forming, na? Why it is? Then CD, how much you are going to take CD, sir? How much you are going to take CD then? This is 10. Okay, first 36. Why ED 11, sir? Why ED to be taken as 11? ED has to be anything greater than this. 7 is enough for this. And this one, in this cycle, big value. So instead of, suppose small value is there, instead of going there, instead of going with this, you may go with this. So it has to be more than 15. So 16 you take here. And this has to be more than these two. So 10 is taken here. Am I clear? So with this, you are going to get the required answer. That is 9 plus 10 plus 2 plus 15 plus 16 plus 17 plus 4 plus 6. So the weight of graph will be, minimum weight of graph will be sum of this, which is I think 69. 69 is the correct answer. let us not think something else. I know we are getting close to the lunch time. I know that. Yeah, Dijkstra's algorithm. Dijkstra's single source shortest path algorithm. Suppose we run Dijkstra's single source shortest path algorithm on the following edge weighted directed graph with vertex P as the source. P is the source here. In what order do the nodes get included in the sets of vertices for which the shortest path distances are finalized? For which the shortest path distances are finalized. See, my dear friends, you can do within the single diagram completely. You start putting the initializing this value. Here you put 0 and all other fellows you initialize with infinity value, because initially they are all at infinity distance. Now actually what happens, there are two things we are going to keep, that is called final order and Q. So the vertices of the graph are entered into this Q, my dear friends, starting with P. Am I clear? Then the remaining fellows, one after the other, what happens, we are going to keep that whatever is having the least minimum weight, that fellow will be joining this. Actually we are going to create not normal queue here, min heap you are going to create. Okay, am I clear? No, yes, where is this? S is also infinity, everything is infinity. Am I clear? Like this we are going to keep, my dear friends. Am I clear? So this min heap, whatever is having minimum cost, now that fellow will join S part out of the previous, because we are going to keep the min heap. So we remove the smallest fellow and that is included in S. That is included in S. So that is the processor. So let us solve it like regular, because with diagram only we can solve the entire story. So we start with P0. Now from 0 where you can go, sir? From 0 where you can go? Update those values. From 0 you can reach Q, that is from P you can go to Q, you can go to S, you can go to T. Can you update the values? 1 is less than infinity, yes. Who is the predecessor? P is the previous one. 6 is smaller than infinity, yes. Update. Who is the predecessor? And previous node? P. 7 can be updated. Previous one is 7. Now here starting with P, next out of these fellows, which one is minimum? See, actually if you keep track of this S and P, S and Q, it would be easy for you. If you keep track of this S and Q, this would be easy for you. What are added here, you will understand better. S here and Q here. Initially P is here. Now what are the fellows which are updated? Q, S, T, R, U. Now Q value was how much, sir? Q, S, T, R, U. Out of Q, S, T, which one is having least cost, my dear friends? Which one is having least cost? Q is having least cost. So you join that Q in S party. Now from Q, you try to update the remaining values. From Q, you can go to this. That is 1 plus 1 is 2. You are coming from Q. 1 plus 4 is 5. 5 is smaller than 6. So you update this 5 and you are coming from Q. Anywhere else? No. So everything is updated. Now out of this 2, 5 and 7, which one is smaller? 2 is smaller, that is R. So R you join this part. R is joining S. Now from R where you can go, sir? From R you can go to S. That is 2 plus 2, it is 4. S it can be updated and it is coming from R. 2 plus 1, it is 3 coming from R. Anywhere else? No. Now out of remaining STU, S is 4, U is 3, T is 7. Which one is smaller? U is smaller. So join U in this, my dear friends. From U where you can go? Nowhere else. So leave it. Now out of S and T, which one is smaller? S is smaller. From S where you can go? S you join the party. S where you can go, sir? From S you can go to only T you have to check, sir, because remaining all are done actually. So from S it is 4 plus 3 7, but it's already 7, it is fine. Okay, 4 plus 3 7, already 7. So you can actually 7 from S also you can go. Yeah, you can go 7 from P also. Both will give you the same answer, my dear friend. Both will give you the same answer, my dear friends. Hope you understand. So that is the idea. So the order in which last one is T. So PQRUST is the order in which the edges, vertices are selected for Dijkstra's algorithm. So in what order does the nodes get included into the set of vertices for which shortest distances are finalized? That is PQRUST. PQRUST. That is option B. And what is the shortest path from S to shortest path from P to R? What is the shortest path from P to R? What is the shortest path from P to R? Shortest path from P to R is 2, my dear friends. And what is that shortest path route? If you want to know the route, who is the predecessor for R? R is coming from Q. For Q, who is the previous no? What is the previous node? P. So PQR is the path. I mean previous one you need. It's not next one, sir. It is a previous one. From there you are coming here. So not only shortest distance, we can also find the path also, my dear friends. You can also find path. So please try this problem once again. Please try this problem. Consider the directed graph shown in the figure below. There are multiple shortest paths between the vertices S and T. Which one will be reported by Dijkstra's shortest path algorithm? Assume that in any iteration, the shortest path to a vertex V is updated only when a strictly shortest path to V is discovered. Strictly means, suppose if same answer is there, here I told you, na, same answer you get it, you don't update it. That is what he's saying. So please answer this question, my dear friends. Starting from S to T you have to find. S to T you have to find the shortest path. S to T. Please answer this question. हाँ, कोई भी ऑर्डर में लिख सकते हैं. एक्चुअली वो नॉर्मल क्यू नहीं होता है, वो मिन हीप होता है. प्रियॉरिटी क्यू होता है, वो प्रियॉरिटी क्यू होता है. टुमारो विल डिस्कस दैट प्रॉब्लम. प्रियॉरिटी क्यू क्या होता है, ओके, कैसे स्मॉलेस्ट नेक्स्ट स्मॉलेस्ट कैसे ले सकते हैं, विल सी इन मिन हीप. एक्चुअली प्रियॉरिटी क्यूज बोलते हैं उसको. प्रियॉरिटी क्यू होता है. ये बी डी है. We have to find the shortest of all. You have to find shortest of all. All are giving same answer. All are giving same answer, my dear friends. Aish Thakur. All are giving same answer. No, I think. Let us see. We started with this. Okay, all are infinity. Yeah, you have to find the proper order. Which order gives you that answer, you have to mention. Infinity, 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 and infinity. So from S, where you can go? From S, where you can go? A, you can go. The answer is 4. You are coming from S. And B, you can go. The answer is 3. Coming from S. D, you can go. I think we written 2 times, sir. The answer is 7. Coming from S. Right. Yeah, maybe the order in which you visited the vertices. So first S is done. Now what is the next shortest one? From S only 3 edges are going out. We done A, D, B. Out of A, D, B, B is the shortest. B is the shortest, so B is included. So from B where you can go D, but 3 plus 4, 7, same answer. We don't update it, sir. And B to S will go, that is of no use. So B is done. After B, next shortest is D or A. A is the shortest, so A is included. From A where you can go only to C you can go. So this is updated. 4 plus 1, 5 coming from A. Now next one is 5 or 7. 5 is the shortest. From 5 where you can go 5 plus 3, 8, which is not updated. 5 plus 1, 6 updated coming from C. Next 6 is the shortest. From 6 here you can go where, sir? We can go to 6 plus 2, 8. This can be updated coming from E. 6 plus 4, 10 coming from E. Anything else? Nothing else. Next from here after 6, 8, 10 and 7. 7 is the shortest. From 7 you can go to E, which is useless. 7 plus 3, 10. Don't update. Then D, 7 plus 5, 12. We update it coming from D. Am I clear? Now this is done because all are updated. Or 7 plus 3, 10 updated. 7 plus 1 updated. So 7 is done. Next 8. 8 fellow. From 8 where you can go? E, it is useless. 8 plus 3, 11 useless. So it is done. Then 10. From 10 where you can go? 10 plus 5, 15 useless. That's it. 10. So 10 means S to T is 10. We are coming from E. You are coming from E. E is coming from C. C is coming from A. And A is coming from S. S-A-C-E-T. Only one path. Because it's not S-C-C-S-A-C-E-T, sir. Only one path. Because he says, this very important point, he says, assume that any iteration, the shortest path to V is updated only when it is a strict shortest path is discovered. Suppose you updated new one, that will not be considered. Suppose 10 is there, again you don't update with 10 only. Already you got 10, now why you need new 10? Okay, so we don't update with same 10. If it is less than 10, then we update it. So according to that, the correct answer is S-A-C-E-T. S-A-C-E-T is the correct answer. See, now it cannot be taken because most of the people may not be interested in that back edge, forward edge, DF tree if you want. Again, that need for application of, graphs. So, not planned for that. Maybe I'll see in next class in coming classes somewhere I'll plan for that. Okay. But today it is not possible. Okay. We'll plan for that. Back edges because that, or otherwise you can just do one thing, Nishu Kumar. In my recorded content, those topics were done in a more detailed manner, like application of graphs. I done so many problems. You can just go through it. Application of graphs I done, BFS, DFS, because if you want to discuss, see, normally BFS discussion is with a Q, you can easily discuss. DFS with, but if you want to understand back trees and all, the terminologies need to be properly defined. Understand DFS in terms of those terminologies. And then the problems, application problem need to be discussed. Oh, sir, it's almost done. One more problem. We're done with this. Last problem. Last problem for today. Last problem for today. So if you like the session, please like, share, subscribe. Now, in Bellman-Ford's algorithm, what happens is all the edges are, that is, edges are taken in some order. Suppose n vertices are there, n minus 1 times you are going to update the values here. Here what happened, here updation happens when a shorter is found. So we are going to do total n minus 1 iteration. See, this Dijkstra's algorithm is a greedy algorithm, where Bellman-Ford is obviously dynamic programming algorithm. So we start here. Actually, we need to take all the edges in some order for Bellman-Ford's algorithm. Thank you, sir. SA, AB, AD, CD, CF. After that, CD, CDF, you done it. You reach it now. Then it is BE. Then it is DE, DG, or FG. DE, let's write down this. BE we write down here. Then here we write down FG. Then you write down DE, DG. Then finally ET, GT. Yeah. See, actually, prims, it is order V, log V. Whereas Kruskal's, it is order V, log E. Because you are going to, order, not, what we written? Did I made it some mistake? 1 second. E log V kaadu kada. Prims Kruskal, I think you made some mistakes, sir. What we done? Bellman-Ford is order E into V. See, order, it's not E Kruskal, it is not E na, V log V only na. Why E log E? E log V. 1 second. I'm in a wrong mood or what? V log E na. V log V. V log E. How, sir? Okay, we'll come to that 1 second. I'll come to that 1 second. See, order V square, you can do it, sir. First, let us complete it. I'll come to that. See what happens in Bellman-Ford's algorithm. First of all, S is there. From S, what happened? Each edge can update the values or not. Initially, this is 0. All are infinity we kept. And this has to be repeated V minus 1 time. That is 9 vertices are there, 8 times you have to repeat. That in any iteration, suppose if these costs are not updated, there you can stop the process. There you can stop the process, my dear friends. Okay. So first let us see, let us update these values or not. Let us see. What I do, I'll put those values for you, okay, in a sheet so that you will not have any confusion there, right? Now SCA is what, sir? 9. So this is 9. Can be updated? Yes, coming from S. Now this one can be updated? Yes, coming from, oh sorry, it's not like this we are going to do. So SCA can be updated. So SCA is 9 coming from S. SC AB. Oh, SC I forgot to write. SC I forgot to write. So let me write that also here. SCA SC. SCA SC you have to write first. Then what happens? It is 9S and it is 1S. So these two can be used. Then AB 9 plus 1 10 can be used coming from A. Then AD 9 plus 1 10 can be used. 9 plus 1 10 can be used coming from A. Next one CD. Where is CD? CD is what, sir? It is 1 plus 1 2 can be updated. Yes, it is 10. So 2 is smaller. So 2 coming from C. CD CF. CF means 1 plus 9 10. It can be updated coming from C. CD CF used. Then BE. BE 10 plus 1 11 can be used. 11 coming from B here. FG. Where is FG, sir? FG 10 plus 1 11 coming from where? F. Got it? Then DE 2 plus 9 11. So same thing, now you can ignore it. Either it is coming from there or here, it does not matter. Then DG. DG. Again DG means 2 plus 9 11. Same thing, need not be updated. Then ET. ET is 11 plus 9 20 coming from E. Then it is 11 plus 1 12 coming from here. That is coming from G is done. So this is one iteration. Now you have to repeat this. Second time when you do this iteration, nothing will be changed here. Second time when you do this iteration means one iteration you updated the values. Now you start with SCA. 9, already 9 can be updated? No. See, when you do the second iteration, no value can be updated. So the least value from S to T is what, sir? From the least value from S to T is what, sir? The least value from S to T is what? It is 12. So how you are going, sir? From T, T is coming from G, G is coming from F, F is coming from C, C is coming from S. So this is the shortest path from S to T, sir. 12 is the shortest path from S to T. See, even though it looks lengthy, but only one iteration, if you properly take the order of the edges, with one iteration only it will be completed. Because second iteration, no updation happen means you can stop the process. Otherwise, you have to repeat this process 8 times. It looks very lengthy. There was a question which they asked last year, like, quality score or something, similar idea. Instead of modifying with the shortest length, you have to modify largest length. You have to update the value with largest length. That was the small trick which you used. Of course, this type of problem sometimes by observation also you can do it. By observation also we do it. See, but the problem is Dijkstra's does not work when there are negative weights. Dijkstra's, there is a problem, it does not work when there are negative weights, my dear friends. When there are negative weight edges, Dijkstra's does not work. Dijkstra's does not work when there are negative weight edges. Okay? Whereas Bellman-Fords can work when negative edges, and if no negative cycle can be found from starting from the source one, then also it works. Negative cycles also it works, but that cycle should not be started from starting fellow. What do you call that? Source vertex. That is the point. Just give me some time. 1 second. So tomorrow 10 o'clock our class, right? I think there's similar problem. This is rod cutting problem. In the previous 2000 last 5 years gate questions, in that I solved this problem, sir. Please see this. And tomorrow, yeah, we start. And we also have this general aptitude conducted by Rakesh sir. 15 hours entire idea of aptitude, 15 marks. The revision strategy by Rakesh sir will be done soon, sir. It will be announced soon. And there is a mathematics session by Rakesh Talreja sir as well as Ankit Joshi sir. That is also coming up soon. Am I clear? Stay tuned. Subscribe, like, share so that we can get this maximum marks. Right? And we also have this test series, my dear friends. We also have this particular test series. Am I clear? Which is having full length mock tests. Okay. And there's all advantages of our test series. We also have this mock analysis. After doing mock tests, most of the people are having this problem, like where they do mistakes. So all these things you can understand with this mock analysis, my dear friends. Yeah, same thing, sir. You people are mentioning like prims and critical. What I do is the complexities I'll write down in a sheet, and I'll put that in together with this PDF. Complexities, all the complexities, just like greedy algorithms, I'll try to put all the complexities. E log V, correct only. E log E, actually for critical it is E log E, but E is of order V square, therefore it can be approximated with E log V only. Prims it is E log V. Prims it is E log V. Last question you want me to solve now. Recently I solved it, sir. You just go through that previous year 2000. Recently I solved it. Just go through it. 2017, 2018, 2019, 2020, 2020. Last 5 years gate questions I solved this problem. You just go through it. It's not difficult. Because I don't have slide for this. That is the problem. You want me to solve it? Anyhow. Huh? Okay, we can go through that. Mr. Nishu, can you go through that previous last 5 years gate questions? I solved the same problem. It was a recent gate question only, na? See, approach is this one, sir. Rn is Pi Rn minus I, where I varies from 1 to n. That is the formula. So when you are having P1, P2, so it's like P values 1, P values, I value, Pi values 1, 2, 3, 4, 5, 6, 7. So it is 1, 5, 8, 9, 10, 17, 18. Now Ri values you are going to find, sir. So we start the table like this. R table is this. I is equal to 0, 1, 2, 3, 4, 5, 7. Rn values, Ri values. R0 is 0 sir always. So R1 onwards you have to use this formula to find it. R1 onwards you have to find this value. Okay. So what is it? What is this value? See, R1 means what, sir? See here. When you want this particular value, P1 plus 0, that is 1. Now, if you want R2, na, according to the formula, what is it? Let me tell you. It actually go from P1, P2. That is, when it is P1, it becomes R1. When it becomes P2, it becomes R0. So, P1 plus R1. P1 plus R1, that is 1 plus 1, 2. Okay. And the other one is 5 plus 0. You have to find what, sir? Maximum amount. Which one is the maximum value? What maximum you are going to take for these two? Is it maximum or minimum, sir? You are going to take? It's not summation, na? Maximum. It's not summation. Sorry. Out of all this, maximum you have to find. Out of all this, maximum I is varying from 1 to n. So it is 1 plus 1, 2, and it is 5 plus 0, 5. 5 is the answer here. Next, when you want R3, for R3, what is it, sir? P3, that is 8 plus 0, that is 8. 5 plus 1, that is 5. 1 plus 5, that is 6. 8 is the largest. Next, for 4, if you want, it is 9. 9 plus 0, 9. 8 plus 1, 9. Then 5 plus 5, 10. And last one is 1 plus 8, 9. 10 is the highest, so you are going to put 10 value here. Next, when you want R5, na, when you want R5, you see 10 plus 0, that is 10. 9 plus 1, 10. 8 plus 5, 13. 5 plus 8, 13. Then 1 plus 10, 11. Highest is 13. You understood, Mr. Nishukumar? These are the values. Maximum of this you have to take it. Maximum of this you have to take it. Hope you understand. Is the idea clear? Yeah. So this is about your marathon part 2, Babu. So next time when you meet, we'll see data structures. Mainly the trees part we'll try to see in the first part, my dear friends. The properties of trees will be discussed mainly. Of course, not just properties, all other concepts. So tomorrow at 10 a.m. data structures part 1, my dear friends. That's all for today. Signing off. If you have any doubts, you can ask me. Not possible, sir, as of now. If possible, we'll let you know. Thank you. Thank you.